Okay, here we go. Here we go. Put those hot little hands up into the air, and let's start talking about what we need to talk about. Delaney. All right, we're going to do a problem like 4F on the first practice test, 4F. Okay, so it's something like this. Okay? So we're solving an equation that looks something like this. All right? What is the first thing that we have to do? Okay. Who knows? What's the first thing I have to do? Madison S. You guys, listen. There's a couple different kinds of problems. We'll do another one here in a second. But there's a couple different situations where you can't do anything until you put these two together. So if you see an equation and it has two logarithms on the same side, you're going to first of all put those together. Now, Madison said that when I put them together, and it's these two we're putting together, that one's fine. He's by himself. These two have to go together. She said because of that plus, this is going to be a multiply. So she said 10x minus 15 because she's distributing, right? Now, once we got them put together, now we have a situation where we have the log of this equals the log of this. When they match like that, when it's log equals log, then blue has to be red. That's it. That's the only way it can happen. So we talk about like dropping the logs, Delaney, or something, but get rid of them. They don't matter anymore. It's 10x minus 15 equals 3x plus 2. And then, let's see, 7x equals 17. I got 17 half, or 17 sevenths. I'm just solving the equation at that point, moving things around to get x by itself. Now, that looks a lot like this. These look a lot alike. And they start exactly the same way. These have got to go together. This time, though, when I put them together, they'll go together as a division. So 2x minus 3 over 8. Always first over second. Now, you're not going to drop this out, because you can only drop them out if you have one on each side. What do we do when we have a logarithm equal to a number? You loop-de-loop. So that's a loop-de-loop situation. You see? It's different than this one. So 5 to the second equals 2x minus 3 over 8. 5 to the second is 25. This is going to be a no calculator problem, but I won't have this big in numbers. 25 times 8 is 200. Add 3. Oops, add 3. And divide. So I got 203 over 2 for that one. Okay, but what I wanted you to see, Delaney, your question was this one, but these two are very similar. So we want to make sure we're keeping them. You know, we start the same way, but then we go do different things. Okay? All right.
Can we do
So basic 5 and 6 actually go kind of along with this, because in problem number 5, it's basically telling you to combine the logarithms just like we combine these. It's not in an equation, but it's the same idea. So you've got something like, 2 log 3 or 2 log x minus 5 log y, and you want to combine those. So instead of having 2 separate logarithms, you're going to have one, just like we did in our equations, right? So how do we combine? Well, we combine either by multiplying or dividing. Since that's a minus, it's going to be a divide, so it's going to be an x over y. Now, what do I do with these other number things hanging around here? They become the exponents. So this is going to be x squared, and this is going to be y, to the 5th. Okay, Avery? Now, the other question, that's one of them. The other one is just the opposite. It says take something like log base 12, you can use whatever base you want, log base 12 of x squared y cubed over z, and expand it. This is called the expansion. Expand it. So instead of having one logarithm, we'll have 3 logarithms, one for each letter. So we'll have a log of x, a log of y, and a log of z. And now we just have to figure out, what are we doing with these? What sign are we putting in there? And what are we doing with these extra numbers floating around? All right? So, what's happening between x and y? Multiply, so the logarithms will be added. What's happening with z? Division, so it's going to be subtracted. And then what do I do with these numbers here? Bring them out in front. The 2 comes out in front of the x. The 3 comes out in front of the y, and that's it. Okay? So these two problems are exactly opposite of each other. This is the one we do in our equations when we put the pieces together to solve them. All right? Who else found something? Madison?
Homework 3.6.
Homework 3.6. Question 3. Homework 3.6. Question 3. All right, so when you were born 18 years ago, parents put some money in their account, paying this, the account is now with this. How much money did your parents originally deposit? All right, which formula?
The other one.
It says compounded monthly. So that's going to be this one, isn't it? Right? Okay. You were born 18 years ago, so T is going to be 18. Your parents put some money in your account, paying 3.5% interest, so R is 0.035. Compounded monthly, so N is 12. The account is now worth 3, 4, 5, 6, 7. And I gotta find what I started with. So this is homework 3.6, number 3. Unless you turned it in today, you have this paper. There we go. Now, am I going to use logarithms? No, I am not. Because I only use logarithms when this is my variable, right? And I know that is actually 216. So So here's what I want you to think about. Don't be intimidated by the numbers, they're just numbers. Just think. You have 3, 4, 5, 6, 7 equals P times a number. Isn't this just some number that I could actually figure out on my calculator? So this 34,000 equals P times a number. And I want to know what P is. Well, what am I going to do?
Divide.
I'm going to divide this 3, 4, 5, 6, 7 thing by that, right? Would everybody agree? Basically, that's what I'm doing. You can actually do that. Just type in exactly what I wrote. So 3, 4, 5, 6, 7 divided by parentheses 1 plus 0.035 divided by 12 raised to the 216. And I got $18,426.99. Now, this will be a problem, and I can't remember who asked about it, but this could be a problem where you typed all this in, rounded it off, like, I don't know, whatever it equals, and then did that divided by that rounded off answer. So basically, you were doing the right thing. The problem is, the moment you round it off, it threw this off, so I'm not giving you full credit for it. There's no need to round that off. Your calculator will do it for you. Let it do it. Okay? All right. What else? Homework quiz, practice test, notes, anything. You're taking a test tomorrow. I wish I were wrong, but I have a pretty good feeling we're not going to have all 100% tomorrow. So what are we going to miss tomorrow? What is the stuff that we're struggling with? Avery?
Practice test 1, 3F.
3F. 3F. So a big exponent step. Let's make that negative 2 just for fun. Okay, so here's our problem. You are allowed and encouraged to do whatever makes sense to you. I think it's easier, really I do. I think it's easier if you forget that for a second and just do this. Fix this. There's a lot going on in there. Let's simplify that. So the 3 and the 4 I can't do much with. What happens with my x's? There's going to be some canceling, and I'm going to be left with an extra 7 on the bottom, right? So x to the 7th on the bottom. Now, what's wrong with my y's? So the 7 has to come down because negatives aren't allowed, right? So we make it positive by bringing it down. When we bring that 7 down, that gives me how many y's down here? 10. Now that's still for the negative 7. I haven't dealt with that yet. Is everybody okay with this? All right. What's that negative do? Flips the whole fraction. So we take care of that and flip the whole fraction. Now I have to square everything, right? Raise it to the 2nd power. So 4 squared is 16. Now, when I raise x to the 7th to the 2nd, what do I do with these exponents? Multiply. So that's x to the 14th, y to the 20th, over, square it, it becomes 9. Yeah, that's it. You can have your own system. system to do that, however it works, but that's the answer. So you wanna make sure that however you're doing it, that's what you come out with as the answer. Kennedy?
Practice test 3, question 2.
Practice test 3, question 2. So write the equation of an exponential. So write the equation of the exponential. You'll be given a couple points, like 0, 7, and 356. I remember those from earlier. Okay? We're going to write the equation of the exponential. What does an exponential look like? Let's get that down first. What's my end goal here? Y equals A times B to the X. Some of you goofballs are finding slope. No. There's no slope in this. This is not a line. This is an exponential function. Your job is to figure out A and B. Well, wait, do we really need to figure out A?
No.
A is right there, right? A is always whatever's hooked to the 0. So you have half credit and you haven't really done anything yet. You got half your answer. Now what do we do? Plug in X, Y, so 56 equals 7B cubed, and solve that. So how do you solve something that looks like that? Divide by 7. And then probably you just know that, right? What's B?
2.
2. Cube root of 8, that's 2. What's that, Tanya?
What?
You act like you were gonna raise your hand.
Oh, I was just gonna ask if you could do a fraction 1 after this.
Yes, I guess, I don't know, find what you're talking about, I'm not sure. Now, remember that you write your answer as the equation. So the answer is going to be 7 times 2 to the X. Ignacio. Okay, why don't you turn your iPad off?
No, I'm using it.
Huh?
I'm doing it.
Okay, well, you're not doing it then. If you're gonna do it, do it. All right, okay, so Delaney, what did you find?
On test 3, number 2 is like that, it has fractions.
Now, I'll do one, I'll figure out one, but I want to remind you, is would the fact that any of these numbers were fractions, would that change anything about my procedure? So what are you telling me? You're at the math. You're afraid of fractions. No need to be afraid of fractions. They're our friends. They work just like everything else, right? So I need a minute to make one up. Okay, so let's repeat the problem. But now our points are I did that pretty quick. I hope I did that right. Yeah. Okay, so here are our points. Your job is to write the equation of the exponential. We are going to do exactly what we just did. So I know already that A equals 2/3. I know that I need to plug in my other point, my non-zero point. So it looks like this. Now how do I solve that? Divide by 2/3, but remember, 1/24 divided by 2/3 is the same as 1/24 times 3/2. 1/24 times 3/2 would be 3/48. Does that reduce? I think it does. I think it reduces to 1/16. And then I figure out what is the 4th root of 16. 2, but it's 1/, so B is going to be 1/2. 4th root of 1 over 4th root of 16. So my equation is y equals 2/3 times 1/2 to the x. Don't be afraid of a fraction. Do the same thing you do with any other number. What, Jersey?
Okay, so one like this, but not this easy. It's like,
Like what? Just show me. What do you mean, but not that easy? It's all that easy.
or maybe I just get confused when the numbers get bigger.
I can't. You gotta quit being afraid because everything's not ones and twos. Alright. Plan this one through. Alright, here we go. So now this is a no calculator problem. This is no calculator. We talked about this, and I hope that you're sort of getting programmed that when you see an X up there like that, you're thinking, ooh, I'm gonna use logarithms. Which is right, but not without a calculator. Can't do it with logarithms without a calculator. So if you wanna use logarithms, but you can't because you don't have a calculator, then the only other thing you can do is make these two numbers match. That's it. So that then you can set the exponents equal. But before I try that, I'm gonna have to do what first?
Divide by 4.
Divide by 4.
27.
Thank you, my friend. Now, I have a 9 and a 27. I have to write them both with the same base number. So what do you think with a 9 and a 27? 3. 9 is 3 squared. 27 is 3 cubed. See how now they have the same base number? So now you can set these equal to each other. That's the only way to do it without logs. So that's a distribute. 2x plus 6 equals 3. 2x equals -3, and x equals -3/2. Now, you're not going to be able to do this with random numbers. We can do it with 4s and 8s because 4 and 8 are both powers of 2. And in all of our practice work, we discovered that 16 is a power of 2, 32 is a power of 2, 64 is a power of 2, right? We've discovered some things. Pretty much all of our problems have been 2s and 3s, maybe a 5 or a 7, running 7 squared is 49. Right? It's manageable. You got it. You got it. All right, what else? Before I move on. This is no calculator. The same, almost the exact same problem could be a calculator problem. So instead of 9 to the x plus 3 equals 27, what if I had 9 to the x plus 3 equals 28? Now it's a calculator problem, right? Now I have no choice. I'm going to have to take the log of both sides. So log both sides. What happens to the exponent? Whole thing comes out in front. What do we do? Divide by log 9. That's a number. That right there is just some number, which my calculator will give to me. And then to get x by itself, what do I have to do next? Subtract 3. So we get to minus 3, and our answer is -1.48. Does everybody see why this is no calculator and that's calculator? The key is right here, being able to make them the same. If it's a no calculator problem, you will be able to do that. I'm not gonna trick you. You're gonna be able to do that. You just have to figure out how. All right, what else? Come on, tomorrow somebody's gonna be panicking or, you know, whatever. I don't do that. It's too hard. It's too tricky. No. In practice to practice, we know exactly what we need to know tomorrow, right? Mitchell? Are you with us here? Okay. You have no questions? A? Tomorrow? Tomorrow's gonna be an A? April? We all heard it.
Can you do practice number 3, 4, D?
4C.
D, as a
D
dog.
as in dog. Where D as in dog is exactly the same kind of problem as this. It's a no calculator problem. And it is exactly the same kind, but I put a fraction in it, right? It doesn't matter, okay? It doesn't matter. So we can have 1/3 5 to the 3x over 8 equals I didn't plan this very well, so I was going to do this. 125 series.
That's actually worse.
Huh?
I don't like that.
Okay. So, what do I do first?
Divide by 1/3.
Divide by 1/3, which is the same as timesing by 3. So however you think about it, the result's going to be the same. We're going to have 5 to the 3x over 8 equals 125. You multiply by 3. Now, this is no calculator. So what did I just promise you? You're going to be able to make them the same base. 5 is pretty much as, you can't really do anything with 5. What about 125?
5 to the 3rd.
It's 5 to the 3rd. You might not know that, kids, but start multiplying 5s together, because you know it's going to be a 5. Multiply 5s together, and it's 5 to the 3rd. At this point, we can set our exponents equal to each other. We'll times by 8 and divide by 3. So it looks like x is 8. Yes. Right there is a 9. Person?
Did you do a growth and decay problem? Did you do a growth and decay problem?
You mean like with bacteria or something? Or what are you talking about? I don't know what you're talking about.
It says 3 questions.
Oh, so is it growth or decay? Yes. So if we have any exponential, so the ones we were writing before, the ones right here, any exponential, is going to be either growth or decay. Because when you graph them, they're either going up like this, or they're coming down like this. That's what, it's your BFF. That's what they look like. So, any exponential, A times B to the X, I can ask the question, is it growth or decay? And you will look at this one and say it is decay. because 0.98 is less than 1. That's the number you look at right there. 0.98 is less than 1. How much less than 1 is it? 0.02, which is 2%. So when we write down our percent growth or decay, we'll say 2% for this problem. And then what's the initial value? That's A. That's your starting value, your y-intercept. Okay, Carson? All right, who else?
I feel like any that have like E in it, but I can't. Like, is E just, you would just put L in, there's no like non-calculator E, right?
There could be,
Or
for example, I think we had, well, certainly we had problems like this that were no calculators.
Yeah, but that's E.
That's it, yes. And we had problems like this. That can be a no calculator problem. What do we do with that? This is a loop-de-loop because it says log base C of 4 equals x. So, oh, actually, that's, it looked like this, I'm sorry. Without a calculator, we have to look like this. There, look like that. So, log base C of x equals 4. So you said e to the 4th equals x. That's a no calculator. Right?
So you just changed the L into an E?
Log base C. ln means log
Yeah.
base C.
Oh.
Then you can do it because it looks like a regular logarithm. All right, one more. I'm just going to throw it out there in case nobody has any other questions. How long will it take for a population of bugs to triple if their growth constant is 0.456? Okay, it's a PERT. How do we know? It's no money, bugs, right? So we're going to PERT it. Do I have an A?
Yes,
Kind of. Because I don't really have a P either, do I? And when I don't have either one of those, I'm allowed to just make something up because I know I'm tripling. So I can make up how many do we start with? How many bugs do we start with? 10. If we start with 10, then we'll end up with 30. And 0.456 T, how long will it take? What's step 1? Divide. And this is why it doesn't matter what you start with. Because see what happens? I just get 3 anyway, right? So if you started with 1 and ended with 3, you'd have 3. If you started with 100 and ended with 300, you'd have 3. All right, now what? Now we're going to take the logarithm of those sides, and the logarithm we're choosing is ln because of the e that's there. So ln 3 equals 0.456t, and t equals ln 3 over 0.456. This is not going to be very long, I don't think. ln 3 divided by 0.456. 2.4 years days, whatever. The reason I said it wasn't going to take very long is this growth constant represents what kind of growth? 45% growth, right? That's big. That's good. Tomorrow's game day. No ifs, ands, buts, or excuses. Eat a good breakfast.